So I'm excited to welcome Team NESTation, who work closely with Ms. J.K. Foss from Nest 360. I was fortunate enough to be their design supervisor. What I liked mostly about them is their prototyping ideas and the way they followed systematically the engineering design process and their incredible prototyping ideas. So they're basically working on a charging, sanitization, and storing station for low resource settings. Let's give a round of applause.
Every year, more than 1 million newborns in Africa will die. 75% of those deaths are preventable. We are Team NESTation. I'm Eleanor, and along with my colleagues Rachel, Michelle, and Peter, we're working with Rice 360 and their NEST program, which aims to reduce newborn mortality in African hospitals by 50%. Part of that mission is delivering and sustaining a package of affordable technologies for newborn care. As of 2020, there were 65 partner hospitals in these 4 countries that had started implementing technologies from the NEST bundle. But implementation is a lot more complex than handing devices over. Currently, there's no system in place for organizing or keeping track of these devices, and few available outlets makes it difficult to keep them charged. These issues increase workload for hospital staff, make it difficult to keep devices sterile in between uses, and can leave devices dead when they're needed the most. Our project addresses that problem.
We aim to design a durable and low-cost solution suitable for low-resource settings to store, charge, and sanitize handheld point-of-care devices in the Nest 360 bundle, such as these devices used to obtain diagnostic results while with or close to the patient, including the Nest Celsi monitor, the BillyDX bilirubinometer, and more. As the first team to work on this problem, we thoroughly analyzed the problem context by conducting 14 informational interviews with leading professionals in their respective fields, including human factors, electronics design, user interface, and more. Through more conversations with our clinical mentor, we learned that our device should also consider power safety and surge protection, the USB type and voltage capacity of each device. It should be accounting for the energy created in the form of heat loss as it is converted, a stationary system, either standalone or on a tabletop, and it should be consumables and disposables should also be accounted for each device, such as Billy strips. From this research, our team decided that our system should be, in order of importance, easy and intuitive to use, low cost, durable with monthly preventative maintenance, have a thoughtful display, be modular, and have portable components.
And with these criteria in mind, we finally move on to our brainstorming stage. And as you can see, this is a lot, and you see that we have really discovered all form options possible. And after the brainstorming, screening, and scoring, we finally moved on with the following 2 prototypes to get into medium fidelity. So we have the bucket building and the unidentified fixed object, or we call it the UFO. So the bucket building is meant to be a standalone, so it's pretty huge, but we did account for the height. So in its final form right now as our medium fidelity prototype, it will be an over-the-top storage with protrusions, and from these protrusions, there will be hangable buckets for storage, and these buckets will come in different sizes to accommodate the different types and number of the handhelds that will vary from hospitals to hospitals. And these are also removable buckets to really hone into the flexibility of our design. And the back compartment is where the charging cords and the other wirings will be organized, and the charging cords will be wired towards the open space charging area right there. And we will be using UVC sanitization for this prototype, and the compartments will be made with clear materials that still block out UVC to still maximize visibility, as it is very important. And the safety mechanism for the door to make sure that no UVC will be leaked when the door is open will also be in place. And there will also be drawers for extra storage at the bottom as well. And next we have the UFO, which is a smaller unit, and this is meant to be tabletop, since we saw a lot of tabletop space in the pictures our clinical mentors have sent to us. So the UFO will have the top level to be of UVC sanitization compartments, and these compartments are made of the same materials and the same safety mechanisms, but they will be in different sizes because the compartments will be accommodating different type of handhelds. And at the bottom 2 levels are the open space charging areas with maximum visibility from all angles necessary. And the side compartments here are meant to be removable, and they can either be used for extra storage or to move the devices around the wards as needed by the hospitals. And this unit of the UFO can either come just like that or with potential extra storage units underneath as well.
Over the past 7 weeks, we've had 14 interviews with our various stakeholders, which includes technicians, researchers, and clinicians to get more clarity on the goals, motivations, and expectations for the project. With the expectations made clearer, we did extensive research that covers the whole problem space and collected over 40 peer-reviewed research reports encompassing the whole problem context. With enough knowledge about the problem, we outlined the clear needs for a potential solution. And then all along the engineering design process, we collected and we wrote and compiled detailed project documentation for the research and the different design decisions that we made. Finally, we managed to design 2 conceptual prototypes that are going to be distributed to our partners for feedback. As mentioned before, we are the first team to ever work on this project, so we hope that the future teams will do the following: test and send the prototypes to our partners and clinicians for evaluation of the form factor, incorporate the feedback and decide on one prototype that will go forward. And then finally, make a higher fidelity prototype that will include full functionality, that is the UVC, electronics, and the user interface. We'd like to thank our partners at RISE 360, OEDK, and Rice University for supporting us all along the way. With our solution, we aim to develop a low-cost device that will elongate the lifetime of NEST 360 technologies, thereby aiding their mission of ending preventable newborn deaths across the world. We thank you very much for listening very attentively, and we welcome any questions that you have.
Yeah, so the question was, are there any key trade-offs between the 2 prototypes, and I guess why did we decide to do 2 instead of just picking 1? I think throughout the process, as we were talking to our clinical mentors, he was clear that we should explore as many options as possible, and that the point at which we would make the choice between potentially tabletop or standalone would come later after clinicians had potentially had an opportunity to see them and think about how they would fit into the ward. So I think our project, as the first team, we really wanted to focus on really understanding the current solution and how something like this would fit into the ward. So I guess, the key trade-off clearly is that one could sit on a table and just be that space, whereas the other would need its own standalone, obviously getting more storage with the larger body of that prototype on the right.
Yeah, they're also both very customizable depending on the specific setting. So if they do want to use the counter space, they can. If they want to put it standalone, they can also have that choice.
So I was wondering if you've had any thoughts about the relative, manufacturability locally, and if you have any specific thoughts or things that you'd like to point out about that.
Is that they can find some materials in Malawi. There's a possibility that it can be manufactured here in the United States, and then it can be disassembled for shipping and then assembled with assembly instructions alongside, and then can be assembled in Malawi.